Alright guys, welcome to this page of the notes. We're going to continue with this theme of solving expressions with exponents in them using the properties of exponents that you guys learned back in Algebra 1. At this point though, the problems just get a little bit more complicated. So I got a couple of example problems for us. We'll work our way through them together. Again, if you feel confident with these, please work ahead. Come on back, check to make sure you get the same answer that I do. And again, there's more than one path to get to the right answer. So please don't think that when you're checking your solutions that if you don't do it my way, you're not going to get the right answer. That's just simply not true. There's more than one way to go about these. Okay, so here we go. I have a quantity raised to a power. I have a quantity raised to a power. So everybody gets raised to that power. Powers of powers means we multiply exponents. So 2 times 4, I now have an A to the 8th. 3 times 4, I now have a B to the 12th. And 2 times 4, I now have a C to the 8th. All right, that's all going to be multiplied by a 2 times a 3, which would be a B to the 6th. A 3 times 3 is going to be 9, so C to the 9th. And an A, oh, that A is to the first power, so 1 times 3 is just 3. I have an A to the third power now. All right, well, so what I'm going to do is go ahead then and combine like bases if I have any. I have an A to the 8th and an A to the 3rd. Add exponents, right? When you multiply like bases, you add exponents. So I have an 8 and a 3. 8 plus 3 should be 11. So how about an A to the 11th power? 12 and 6 should give me B to the 18th. And then I've got 8 and 3. Sorry, 8 and 3. I have an 8 and 9, C to the 8th, C to the 9th, which should be 17. So C to the 17th. Oh, hang on, that C got weird on me. I like it. I don't have anything else to simplify. I don't have any other like terms to combine. You're all set on that one. Let's jump on down to this one right here. Quantity raised to a power. So I just need to make sure that I raise everybody inside the parentheses to that power. That means I'm going to have a 2 to the 8th power. Again, feel free to use a calculator for that. 2 to the 8th power is 256. I have an x squared raised to the 8th, so 2 times 8 would be 16. I have a y to the 3rd and an 8. So I'll need to multiply 3. 3 times 8, which is of course going to be 24. 4 times 8 will be 32, so z to the 32nd power. Negative exponent. Okay, so here we go. I have an x to the first, x to the first raised to a negative second, multiply exponents. 1 times a negative 2 would be a negative 2. So I now have an x to the negative 2. I'm going to have to take care of that here in a second. I also have a y to the first, so I will have a y to the negative second as well. I'll need to take care of that. A z to the second to the negative second, so multiply exponents. How about a z to the negative 4th? All right, so I got a couple of negative exponents here I'm going to need to take care of. Again, I would, if I were doing this normally, I would go ahead and take all those guys to the bottom and then cancel. But it's just as simple to do it right now. I know that I have 256. And when I multiply like bases, I have to add the exponents. Well, 16 plus a negative 2 would be x to the 14th. Y to the 24th times y to the negative second. You add the exponents. 24 plus a negative 2 would be y to the 22nd. And then z to the 32nd and a z to the negative 4th. Add the exponents, which should give me z to the 28th. I know, gigantic exponents, but that's okay. It'll happen. And again, you certainly could have just taken this, dropped it into the bottom, and then canceled like terms top and bottom. You would have wound up with the exact same answer. Got a couple more for you on the next page. Jump on over here. Let's make these guys a little bit bigger. See what happens. Okay, I'm going to raise everybody to the negative fourth power, so 3 times negative 4 is going to give me a to the negative 12. 2 times the negative 4 is going to be b to the negative 8. And 4 times the negative 4 is going to be x to the negative 16. 2 to the negative 4th, x to the negative 8th. 3 times the negative 4 would be y to the negative 12th. And again, 3 times the negative 4, so c to the negative 12th. Okay, here's what I'm going to do. Since everybody in the top is negative and everybody in the bottom is negative, I just flip the fraction. That'll make all of my exponents positive. X to the 8th, y to the 12th, c to the 12th, right? I take all of these guys in the bottom, put them in the top, all their exponents will now be positive. I then take everybody who is in the top, move them to the bottom, and all their exponents will be positive. And then I need to look for like bases. I've got x and x. Okay, so when I have division of like bases, I subtract the exponents. 8 minus 16, that's going to leave me with x to the 8th in the bottom. I don't have any other like bases, so it's going to be y to the 12th, c to the 12th, all over a to the 12th, b to the 8th, and I'm left with an x to the 8th in the bottom. Again, 8 of the x's in the top cancel with 8 of the x's in the bottom. But you have 16 x's in the bottom, so that's going to leave you with 8 of those x's left over. That will be your final answer right there. Yeah, I got another one here for us. Let's do this one. Okay, rather than go ahead and take care of the minus signs like I normally would do, let's just jump right into combining like terms. So a and a, which means I'll subtract the exponents, which means that I will have a to the negative 3rd minus a negative 4. Interesting. I then have a b to the 2nd, so that's going to then wind up being a b to the 2nd minus a negative 3rd, right? Because I subtract the exponents, top minus the bottom, that's b. And then I'm going to have a c to the negative 2nd minus a negative 4, right? Subtract the exponents and let's see how this comes out. Add a line, change the sign, so I'd have a negative 3 plus 4, which would be an a to the 1st. Add a line, change the sign, so I have b to the 6th. And I will add a line, change the sign, so I have a negative 2 plus 4, which leaves me with c squared. I don't have any fractions to simplify. I no longer have any like bases. And I certainly don't have any negative exponents, so you have completely simplified that problem as well. All right, guys, what we're going to take a look at then on the next page of the notes is what we're going to do when it comes to operations with polynomials, adding, subtracting, and multiplying. So head on over to the next page of the notes. I'll meet you guys there.